To remind you, I go 1, 2, 3, 3, 2, 1. These are all divided by 2. And all the numbers in the numerators are square roots. Yeah, okay, you can, yeah. Tan then is 1 over root 3. Sine, or tan of 30 is 1 over root 3, 1 divided by root 3. Root 2 divided by root 2 is just 1. And root 3 divided by 1 is root 3. Cosine, so now we're looking at 90 degrees. That's that complete. Now we're looking at 90 degrees. This is what you kind of will look at in the table, in the unit circle a little bit more. The cosine of 90 degrees was going 3, 2, 1, 0 if you do that one. Once you know that one is 0, this one's increasing up to 1, and this is 1 divided by 0, which is undefined. So we did that yesterday. And now we're looking at the fact that we can look at angles greater than 90 degrees using a circle. As the angle increases going this way, we're looking, so that this quarter of a circle incorporates all angles from 0 up to 90, yeah? So an angle here would be like 10 degrees, 20 degrees, 30 degrees, 40 degrees. So the outside of this circle is tracing a bunch of angles. I'm going to say that this has a circle of unit 1. I'm saying its radius is 1. And I'm going to continue this circle, so we're looking at angles beyond 90 into 270. And hopefully you can draw it better than me if you're drawing it. You'll never ask to redraw this, so you can just watch if you don't want to draw it. So we're looking at a bunch of triangles created by this unit circle. I'm looking, for example, at this triangle here. We can create a bunch of these triangles, but I just want to look at this one. And I'm going to call this an unknown angle. I don't know what it is, so I'm using a theta symbol. What's the distance of this line here, from here to here? 1. So I'm using a circle of radius 1, so this is also 1. The same as this length here is 1. Okay, so as this goes around, it's still going to be 1 all the way around. Okay? Yesterday we were looking at sine, cosine, and tan. So if I look at this length here, let's call it x. Just this length of this, I want to find out what that length is. I can use sine, cos, tan. Which one can I use if I know this angle? This side, according to this angle, is the adjacent, and this one over here is the hypotenuse. Cos, very good, yeah. So cosine of an angle is the adjacent divided by the hypotenuse. We went through that yesterday. So the cosine of this angle is the adjacent side x divided by the hypotenuse 1. Now, if we divide anything by 1, it doesn't really do anything. So I can say that the cosine is just, cosine of the angle is just that x length. So this length here is an x. It is the cosine of the angle. So that decimal that has been created. So it might be like 0.5 or something in length, the cosine of that angle. And if we do the same thing for the sine of the angle, which uses the opposite side, we can call this y if you wish, is y over 1 as well. Opposite over hypotenuse. So y over 1, so sine of the angle is y. So remember, sine and cosine of angles are just numbers. The numbers range between what two values? What's the lowest possible value for sine and cosine? Okay, -1 is correct, yeah. But we're looking at in this quadrant between 0 and 1. Like all these numbers, they are decimals. These are just ones that we know make nice surds or a nice fraction. But quite often, the angle will just make a fraction that's not a nice decimal. It'll make like something like 0.763. Which doesn't fit one of these nice ones, because angles aren't always 30 degrees, 45 degrees, 60 degrees. So cosine of the angle will just be some decimal number between 0 and 1, and the sine of angle will be some decimal number between 0 and 1. With our knowledge of points, this point up here has an x-coordinate and a y-coordinate, doesn't it? Using the x-axis and the y-axis. But we know the x-coordinate is the same as cosine theta. So I'm going to say that x is cosine theta and y is sine theta. So any point, I can do this for any point around this triangle or around this circle. Maybe you can see it definitely from here to here. I can see that it's going to be just cos theta, sine theta. If I just draw this triangle over and over again, and the radius is always going to be 1, and I'm going to always get cosine theta, sine theta. Okay. So if we did a specific example, which I'll do over here, we have a unit circle, we do a specific example of, let's say this angle here is 60 degrees. What's the point up here if that angle is 60 degrees? The point will be, so the x value of it is going to be the cosine of 60 degrees. And that's where I use this table. The cosine of 60 degrees is a half. And the sine of 60 degrees will be this bit. So the sine of 60 degrees is, from this table, root 3 over 2. Okay, so you actually get a point. It's related to, it's like parameters have changed. And we could draw another one then, if you want to draw another one for 45 degrees, let's say. So this is 45 degree angle. What's this point up here? Maybe we can do it quicker now. No, it'd be the cosine will come first. So the cosine of 45 degrees would be the x-coordinate, which is root 2 over 2. And the sine of 45 degrees would be the y-coordinate. Okay. What happens, though, when we go beyond 90 degrees? We can see, perhaps we can see now that the reason cosine of 0 is 1 is when this line is starting off, that cosine length here is 1. The x-axis length is 1, and that's where we got, we haven't written it here, but if we had cosine of 0 degrees, it's 1, yes. And as this spins around and comes up here and we hit 90 degrees, so that's a 90 degree angle here, that's why the sine is 1. And the cosine is nothing, because this point here is 0, 1. What happens when we go beyond? Well, let's just stick with our every 90 degrees. What's this point over here? From our knowledge of coordinate geometry, it's minus 1, 0, which means, what can I say about the cosine of 180 degrees? It must be minus 1, because the cosine is always with the x-axis. We've just proved it here. As it goes around, that will be minus 1 when it hits 180, and that means the sine of 180 degrees is 0. What about down here at 270 degrees? So we'll add another 90 degrees. The cosine of 270 is 0, because this is the point, 0 minus 1. But what you may be noticing now is that the signs are changing. We're now getting negative numbers for the ratio of an angle. We're getting negative numbers sometimes. And it depends what quadrant it sits in. So you can see that every cosine angle here, the cosine of every angle is going to be negative here in this quadrant, between 90 and 180. Do we see that? Because the x-coordinate will always be negative. All the x-coordinates, if you're just plotting on your Cartesian diagram and you have a coordinate over here, that x-coordinate is definitely negative, but the y-coordinate is definitely positive. We're always thinking about the x-axis as the cosine and the y-axis as the sine of the angle. So we can now make some assumptions that all points here are positive, aren't they? Points in this quadrant is like 1, 1, 2, 2, 3, 4, 5, 6. They're all positive in this quadrant. All the points. What's positive in this quadrant? Sine. Is cosine positive? No, because the x-axis is negative. What about tan? Okay. Well, tan, if we remember, is sine over the cosine of the angle. That's how we created this. 1 over root 3 gave tan here. So if, from our knowledge of number, sine is positive and cos is negative, because we just looked at that, what will tan be? A positive divided by a negative is always negative. It's always negative. So tan is negative here. So the only one positive is sine. The other two are negative. What about here? Sine and cosine are both negative, which means that would be a negative divided by a negative, which means tan is the only one positive here. And we're left with just cosine is positive here. This is a useful diagram to have. The other ones are negative. Only sine is positive, cosine tan negative, sine cos negative, sine tan negative. Because we're getting negative values out as we go around. Okay. So earlier on we looked at 60 degrees on a different angle. Let's just continue to look at 60. It's a good one to look at. That created this point up here from cosine 60 being a half and sine 60 being root 3 over 2. That created this. So all the rest of the angles are just reflections. They're just reflections in either the x or the y-axis. So this angle over 60 degrees is like a reflection angle over here. What would that angle be? If I went all the way around to here and created this angle, what's that angle? Well, yeah, so this angle would be 60 for it to be a perfect reflection, but we always start counting from the x-axis. So this angle all the way around to here is actually what? 120, yes. So we're looking at 120 degrees. We're looking at this angle. What is the sine of 120 degrees? And what's the cosine of 120 degrees? And what's the tan of 120 degrees? Well, it's a reflection of this point. This point will be the same over here, but it will just have one sign change. Negative. Which one will be negative? X will be negative. Why do I know that? A tan will be negative too, yes. But of these 2 points, sin is going to be positive, sine is going to be positive. This is going to be negative. It's just this point reflected over. So it's minus a half root 3 over 2. It's the same point over here. And what's the tan of 120? Minus root 3. Remember, we're looking at 60 degrees. Okay. So we have to get like a system in place that we can do all angles around this circle using reflections. We use something called a reference angle. What was the reference angle for? The reference angle is one of the angles 30, 45, 60, 90. What was my reference angle when I went to 120? 60. I referenced 60 from my table because it'll be a reflection of these points. Okay. Let's do another one. I'm going to put some up on screen. We're going to do a bunch, and then you'll do a bunch. And we're going to try and get quicker at this. I'm not going to do 60 because we already did that. We're going to do 150, which is the second one here. So I'll remove this. We'll try and remember it. We're going to look at the sine of 150 degrees, the cosine of 150, and the tan of 150. And we're going to put the answers here after we have a little look at it. Let's have a sketch. I like to draw a sketch and figure out what quadrants it's in. Is it in this one, this one, this one, this one? That's first, second, third, fourth. Which one is in? Second. It's also in the second. So 150 degrees, that's 150 degrees. 150 degrees is not in my table. But I can use a reference angle from the table. Which one will I reference? 30. Why 30? Because it's this angle here is 30, yes. And it has a reflection over here of 30 degrees. So it's going to be the same point as 30 degrees, but there's going to be some sign changes. So it'll be all the answers the same as 30 degrees, but some of the signs might be different. But you can write down the answers, and then we can think about the signs afterwards. These are definitely the 3 answers, but the signs might be wrong. Which signs do I need to change? Cos and tan, yes. Because we figured out that remember, sine is the y-axis, so that y point is going to be positive, whatever it is. And the cosine is the x-axis. That's definitely negative, because it's this side of the 0, 0. And tan is 1 divided by the other, so positive divided by a negative. So I found my reference angle, I just wrote in my answers, and then I figured out if it's positive or negative. You don't need to double it or triple it or do anything like that. You just use the reference angle from this table. Okay, let's do another one. Let's look at, what's that, 225. So we're going to do the sine of 225, the cosine of 225, and the tan of 225. Now this is a more difficult one because this is clearly not in the first or second quadrant because 180 degrees is this far, so it's past that.
Sorry, I have a question.
Yes?
For the radius circle you just drew,
Yeah.
could you apply tan inside the circle or anywhere? Like why would you use tan?
Why would you use tan?
Yeah, or like why would you need it anytime?
Well, tan comes up in a lot of questions. It is in the unit circle because we use the hypotenuse as 1. It's not as useful, but yeah, if the hypotenuse was a different amount, then it would be different. So we got to use the sine over cos version of tan. Okay, so we want to find the reference angle. So which one? Yeah. Okay.
No, why did you write the sense of 150 is 1 divided by 2?
Sine of 150 is 1 divided by 2. So we found the reference angle was 30 degrees. And it was a reflection of that. It was over here. So sine's still positive in that because it's with the y-axis.
But why did you write the point different?
Here? Oh, that's 60 degrees. That was a different question. Yeah, so that's a different question. I can get rid of that. Okay, so we're a starting point here. We're not sure what to do. Let's find out where it is about. I think it's around here, isn't it? Past 180 degrees. How much past 180 degrees? 45 past 180 degrees. So notice what I'm doing. I'm looking at this axis to create my reference angle, to find my reference angle. Now the only one that ends in a 5 is 45. That also is the little bit of a hint. So this is all the way around to here is 225 degrees. So that means my reference angle is some reflection of 45 degrees, which is actually over here, but it's a reflection in 0, 0 if you want. Okay, so I use 45 degrees, which means I can go straight away to this table and just put in these values for 45 and then figure out the signs afterwards.